Okay, complex eigenvalues. This matrix is going to give us complex eigenvalues. And of course, we know our equation is. Incidentally, I think your book uses P of t, capital P of t instead of A. I'm going to stick with A because you're more used to it from linear algebra. But when you read your book, I'm going to put P of t where I'm putting A, and that shouldn't cause you any problems. Okay, so anyhow, we just skip to the chase. The determinant of A minus lambda I is determinant 1 minus lambda 1, negative 1, 1 minus lambda. Okay? And that's going to be a plus 1 there, so we're going to have a 3. Remember last time we had a negative 3. So this is very similar to the matrix that we had in the previous example, except that now we've got a plus 3. And clearly that's not going to factor. Okay? And don't worry, you can evaluate it, but I'm pretty sure that's correct. So this tells us that lambda is going to have to be 2 plus or minus the square root of 4 minus 12, which is negative 8, over 2, which is 1 plus or minus I. Okay? I don't know that they worked that through in the example you have there.
How did you get that 3?
I did this determinant, just do it. I get a 1 from here and a minus negative 1 from here. And that's not 3, is it? No, I'm glad you asked. Okay, that's 2. And actually, yeah, I've got too many 2's in there. Okay, so this would not be negative 8. This would probably be negative 4 because I'm going to have 4 minus 8. Yeah, okay, negative 4. And now this comes out what I said it did. But my solution was right. I divided by 2 one too many times over here and didn't do it carefully, or I'd have realized that there's something wrong. Okay? Okay, so anyhow, we got 1 plus or minus I here, right? So, for lambda equals 1 plus I, so we don't have to worry about a negative sign. And this is really all we've got to figure out, because the solution for 1 minus I is going to be easily identified from the solution for 1 plus I. You see? Okay? For lambda equals 1 plus I, we get the determinant, the matrix 1 minus 1 plus I, 1, negative 1, 1 minus 1 plus I, times the AB equals a 0 vector, which I'll go ahead and write out in the column vector. Okay? And then we simplify this, and we get I, 1, negative 1, I. Okay? And it should be negative I think. Okay? This gives us 2 equations. Let's just do them. And
Why do you get 2 equations?
well, this times this equals 0, this times this equals 0.
Yeah. I thought they're always supposed to be.
You've got to see that they're multiples of each other. Do they look like multiples of each other? So we better see why. So that's why I'm writing them out. So we have minus A plus bi equals 0, right? Well,
You would have a minus bi for your second equation.
thank you. Okay. And this one implies, well, minus bi would equal minus a, right? So b would equal a divided by I. Would it be negative a divided by I? Okay? If I multiply the numerator and denominator here, I get negative ai over negative 1. So I'll even write that. Negative ai over I squared, which is negative ai over negative 1, which is ai. They give you the same solution. Also, if I multiply the second equation by I get negative ai plus b equals 0, right? So my point is that complex numbers, you got to deal with them a little bit carefully until you get used to such things. Okay? But it works out, and you see that it worked out. And if you don't totally see it, work it out yourself, because the arithmetic is really simple. You got to be used to complex arithmetic, which is again another thing that it's really easy. You might have to practice it a little bit. Yeah, can you multiply or add two complex numbers? Certainly. Can you divide them? You got to multiply by a conjugate. Okay? And I'm not going to do that. That's algebra 2 worse. So that's just something you got to deal with. But it's really easy. My pre-calculus students don't have any problem with it if they do the work. It's one of the easiest sections in the book. Okay, but you got to be used to it. So it didn't look like that was going to be a multiple of this. Okay. And when I looked at it, I said, it's going to work when we multiply by I. But I didn't work it through because I knew it would. You know. Okay. But still, you know, given that I'm, you know, a little careless with my arithmetic, I was a little relieved when it worked out. Okay. Okay. So anyhow, you've got your solution, right? So one solution is e to the 1 plus I times I got it backwards. Now it's all smudged. Okay, that reads 1i. Okay? Now does b equal ai? Well, a is 1, and you multiply it by I, you get I, which is b. So let me make that legible, at least halfway legible. Okay? And it's keep forgetting to write my T in there. Okay. Shades of my youth. When doing sines and cosines and simplifying trig functions, I stopped writing theta. Okay, there's focused on the sine and cosine and other things. So y1 equals this. Now, this is this, right? So here's our y1 function. And it should be no surprise to you that when we have complex valued eigenvalue, just like when you have a complex solution to your characteristic equation, you end up using Euler's identity and getting sine and cosines. Okay? And if we multiply this through, we just keep the e to the t out front, but then we'll have a cosine t plus I sine t here, right? And then we got to multiply by I, which is going to give us a negative sine t plus I cosine t, right? Now you write that out, and you get used to those patterns when you've done several problems, okay? And the problems, at least the first few problems, are going to be pretty straightforward. Okay, well, we could go through the whole process to get y2, okay? And without tracing through just what would change, well, we have a negative I here. So we'd have negative i's here, so we'd have positive i's here. Well, what it comes down to is we end up with a complex conjugate. We end up with e to the 1 minus I t. Okay? So y2 is going to be e to the 1 minus I times t times eigenvalue, and it's going to be 1 negative I. Okay? You just replace your i's with negative i's. And there you have it. There's your solution set. Okay? So the complex case is in some ways simpler because once you've got one solution, you just do a conjugate and you get the other solution. Geometrically seeing what this means in the plane and stuff like that, it's more complicated. But other than that, the process of getting from here to here is just a matter of, okay, we got a negative under the radical and we solved the characteristic equation. So we're going to have complex eigenvalues. It's no big deal. We just do what we do. We solve the equation, being careful to use correct complex arithmetic. Okay? And we can write down our solution. We get sines and cosines times exponential functions. Okay? Having one solution, we use conjugate and we get the other. So there's only really one solution we got to worry about. So in that sense, it's simpler. In the sense that you got to do complex arithmetic, well, it's a little extra arithmetic. And you got to be a little more careful if you're not used to it. So it's really no big deal.